Just stating the numbers that you know. If you start at 1, 0 and rotate forward by an angle of no radians, then where do you land? 1, 0. And the same thing for 2 pi. Right? If you go all the way around the circle and come back to where you started, then your endpoint is the same as the point where you started. So that tells you that cosine of 0 is 1. It also tells you that cosine of 2 pi is 1. It tells you that cosine of 0, sine of 0 is 0. It also tells you that the sine of 2 pi is 0. All right, same thing, but what if you rotate all the way up to an angle of pi over 2? So you do a quarter of a full revolution. Then what point do you land on? 0, 1. 0, 1. So cosine of pi over 2 is 0, sine of pi over 2 is 1. If you rotate by a half revolution, negative 1, 0, finally 0, negative 1. So those are like the points that it's, in some sense, obvious that the function should be. Yeah.
Do you have an extra sheet?
Yeah. Anyone else not get copies of things? Okay. There should be 2 handouts. This one and the other one, which is many sheets. There are some other things that we computed last time. Let's remember this from last time. What's the cosine of pi over 4? What about the sine of pi over 4? Same. So that tells you if you rotate counterclockwise by an angle of pi over 4, that puts you at that point. So what is the x-coordinate of that point? Root 2 over 2. And what's the y-coordinate? Nice. We also computed last time the cosine of pi over 6. What did we get for the cosine of pi over 6? Root 3 over 2. Now what did we get for the sine of pi over 6? 1. So let's fill those in. So if you rotate forward by an angle of pi over 6, you land at root 3 over 2, comma, 1 over 2. And in fact, by studying the exact same triangle as we did for to study pi over 6, we got information about pi over 3. What's the cosine of pi over 3? 1 half. Sine of pi over 3? So it tells you that this point must be 1 over 2, comma, root 3 over 2. And trig functions, at the very least, at those 3 inputs are things that you should just internalize. I'll allow like a note sheet containing this on things like exams, but you'll be using them enough that the intent is those numbers just become engraved in your head. On the other hand, maybe you just like notice already that the numbers go 0, 1 half root 2 over 2, root 3 over 2, and 1, which happens to be the same as root 4 over 2. So if you can remember that the numbers in there should be root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, and then you can just put them in the right order to figure out which one goes in which entry. So there's a way that you can just remember that. It's not a proof that that's correct. But let's figure out the rest of the entries in this unit circle. And maybe it seems kind of obvious. How do you think you would want to go from this entry to that entry? What symmetry of the plane seems to do it? Yeah, making the x negative, so reflecting over the y-axis. So in some sense, that tells you what should go there. but it also tells you an important fact about trig functions. Similarly, if you wanted to go from these to those, it looks like you want to reflect over the x-axis. And that'll tell you what entries go down here, but it'll also tell you a bunch of facts about the trig functions. So as we figure out what goes in these spaces, we'll also figure out identities that trig functions just satisfy. So let's go ahead and start. So other than filling out this unit circle, our other goal is figuring out what these operations do to the trig functions. What changing an angle by 2 pi does. What changing an angle by, no, I don't want to do anything with those. I want all those lights on. What do I do? I want to increase the brightness on this. Better? Okay. I want to figure out what going backwards by an angle does to trig functions. If you like, this is like asking, are these functions even or odd? I want to figure out what happens when I go forward by an angle of pi and then go back by this angle theta. What does that do to trig functions? So let's go ahead and get started. Let's start with the one that maybe seems the most obvious. Let's think about what happens when we add a multiple of 2 pi to an angle. So k is a whole number, an integer. 2 pi corresponds to what? So well, how about this first? 2 pi radians corresponds to what kind of angle? What is 2 pi radians? A 360-degree angle, also known as a full revolution. So 2 pi k radians is just k times 360 degrees, or k full revolutions. So if you want to understand an angle of theta plus 2 pi k, so 2 pi k radians corresponds to k full revolutions. So you can think of a rotation by an angle of theta plus 2 pi k as first rotating by k full revolutions, and then rotating by an angle of theta. So pictorially, there's the unit circle. I'll start at 1, 0. I'll do a bunch of full revolutions. If I start at 1, 0 and I do a bunch of full revolutions, I land back at 1, 0. And then I go forward by theta. Did the full revolutions actually have any impact on the point where I land? No, so. No. So that means that the x value, when you rotate by theta plus 2 pi k, is just the same as the cosine of theta. The sine of theta plus 2 pi k is the same thing as the sine of theta. Secant is the same thing as secant theta. Cosecant is the same as cosecant theta. Tangent is the same as tangent theta. Cotangent is the same as cotangent theta. So whenever you see a plus 2 pi k inside of a trig function, you can throw it out. Nice. And putting these, I'll flip back to this first page an awful lot. Cosine of theta plus 2 pi k is the same thing as cosine theta. Sine of theta plus 2 pi k is the same thing as sine of theta. You'll notice that in the document I wrote down some facts about tangent and cotangent and secant. Isn't it? Do you think you can remember those if you just remember that same fact for sine and cosine? Yeah, tangent is like determined by sine and cosine. So if you know what sine and cosine do, you can figure out what tangent is. Nice, so there's the first entry done. Cool. So let's think about the next thing in the list was either starting at 1, 0 and rotating by 2 pi minus theta. That's the same thing as rotating over by 2 pi and back by theta, which on the other hand is the same as just rotating backwards by theta. So let's look at these two pictures. So here's the picture where I start at 1, 0 and I rotate up by theta. Here's the one where I start at 1, 0 and I rotate down by theta. What symmetry of the plane relates those two red lines? the x-axis, doing the reflection that makes the y values negative. Reflection over the x-axis. What does this do to xy coordinates? Let's see. What does it do to the x coordinate? Stays the same. What does this do to the y coordinate? You stick an extra negative sign in front of y. So let's write that out. So that means cosine of negative theta, it's the same thing as cosine of 2 pi minus theta, is the same thing as the new x coordinate, the x coordinate after you do the reflection. But how does the new x coordinate compared to the original x coordinate? They're the same. So that's this x coordinate. But what is the x coordinate that you started with? Which trig function gives you x? Cosine. Cosine. So that means cosine of negative theta is the same thing as cosine of theta. Same thing for sine. The sine of negative theta, that's like the new y coordinate, so the y coordinate on the right-hand side. How does the y coordinate change when we reflect over the x-axis? It becomes negative, right? Yeah.
Inverts.
Yeah. The y gets an extra negative sign in front of it. So that'll be negative. Which trig function gives you y? Cool. So there are some facts. Do you think we could use that to figure out the other trig functions now? Maybe I'll talk through secant and tangent, and then I'll give you guys a little bit of time to think about cosecant and cotangent. So let's figure out secant. So if I want to compute the secant of negative theta, let's think of it in terms of sine and cosine. What is secant in terms of sine and cosine?
1 over sine.
1 over cosine, which is maybe counterintuitive. Cosine becomes secant, sine becomes cosecant. So that's the same thing as 1 over the cosine of negative theta. Okay. But cosine of negative theta, what's the cosine of negative theta the same as? Just the cosine of theta. Wait, so there's still the 1 over, isn't there? So I get 1 over the cosine of theta. But what is 1 over cosine of theta the same as? Secant theta. So that means secant of negative theta is the same thing as the secant of theta. Fair enough? I'll talk through the same thing for tangent, and then I'll maybe have you guys figure it out for cosecant and cotangent. So let's try to do it. If I want to compute tangent of negative theta, well, I know what sine and cosine do. So let's rewrite tangent in terms of sine and cosine. What is tangent in terms of sine and cosine?
Sine over cosine.
Sine over cosine. So tangent of blah is the same thing as sine of blah over cosine of blah. In this case, blah is negative theta. So tangent of negative theta is sine of negative theta divided by cosine of negative theta. And now let's play the same game. What's the sine of negative theta? Negative sine theta. What's cosine of negative theta? It's cosine theta. So I get negative sine theta over cosine theta, and what is that? Negative tangent. So tangent of negative theta is negative the tangent of theta. How do people feel about that? That seem okay? So here's what I want you guys to do. There's cosecant and cotangent left in the list. I think I will say this half of the room should think through cosecant, take a few minutes. This half of the room will think through cotangent, and then we'll come together and write down what the resolution is. Maybe it would be useful to do this, though. Called the variable star because apparently throughout this I'm going to be plugging in something other than just theta. So once you have some answers, you can compare them with those around you for the one that you're supposed to compute. People feel pretty ready? So tell me, what is the cosecant of minus theta?
Negative cosecant theta.
Negative cosecant theta? And cotangent of negative theta is? That was this side.
Negative tangent of cotangent of theta.
Yeah. Does anyone want me to talk through either one of those two? Okay, cool. Let's maybe even link on this for another second. So looking at that fact, is cosine even or odd? Even. Right, it's a function. You stick a negative sign in front of the argument, it stays the same. What about sine? Is sine even or odd? Odd. A function which has the property that when you stick a negative sign, negative inside of the parentheses, you can pull it out. That's called an odd function. Let's put that on the front page. So here's the second of these. Cosine of 2 pi minus theta is the same thing as cosine of negative theta, is cosine theta. Sine of 2 pi minus theta is the same as sine of negative theta, is the same thing as negative sine theta. So cosine is even, sine is odd. Nice. Everyone feel pretty okay? Let's take advantage of that to figure out what we can determine in this page. So I know that if I do 2 pi minus an angle, I know what that should do to trig functions. So here are some angles. Let's see what happens when I put a 2 pi minus in front of them. So cosine of 2 pi minus pi over 6. What happens when I replace an angle by 2 pi minus that angle? What happens to cosine? Does it become negative or stay the same?
Stays the same.
Stays the same. So this should be the same thing as the cosine of pi over 6. let's walk through this. What's 2 pi minus pi over 6? (11 pi over 6, right? So that tells you that the cosine of 11 pi over 6 should be the same thing as cosine of pi over 6. But what's the cosine of pi over 6? Root 3 over 2. Similarly, what is the sine of 11 pi over 6? Not quite. Negative 1/2. Because, right, so that should be the same thing as the sine of 2 pi minus pi over 6. Am I going behind the screen for people? Is it still visible? Okay, no one is complaining. So that should be the same thing as negative the sine of pi over 6. That's negative 1/2. So that tells me some numbers. That tells me what goes here should be root 3 over 2, comma, negative 1/2. Which agrees with what you knew it should be, right? It should be the result of reflecting over the x-axis, and that's what happens when you reflect over the x-axis. Similarly, what should the cosine of 7 pi over 4 be the same as? Same as the cosine of pi over 4. And what's the cosine of pi over 4?
Root 2 over 2.
Root 2 over 2. So that should have x coordinate, root 2 over 2. And what should its y coordinate be?
Negative root 2 over 2.
Negative root 2 over 2. 5 pi over 30. Let's do sine first. So the sine of 5 pi over 30 should be the same as what?
Negative root 3 over 2.
Well, it should be the same as the negative of the sine of root 3 over 2. You dropped the word sine in what you said. So it's not going to be literally root 3 over 2. It will be negative the sine of root 3 over 2. So the y coordinate at 5 pi over 3 should be negative this number. And the x coordinate will be positive that number. That make sense for everyone? That seem reasonable? And my intent in these notes is not to get through all of these notes in one day. These notes are intended for approximately 2 days. So I feel like I'm pretty okay time-wise. So an application of this in general. So we just saw how these things can be used to take trig functions that you know and move around that information. If you know a number in quadrant 1, you can reflect to get a number that's in quadrant 2. You can know that number. Let's see this in practice. So here's a fact that we won't establish until quite a while from now. It turns out that the cosine of pi over 8 is the square root of the square root of 2 plus the square root of 2 all over 2. I'm not going to tell you why that's true. Won't do that for quite a while. I'll drop the buzzword half-angle identity if you like. As a consequence, as soon as you go home, you can go and look up the half-angle identity because you just have the book. But let's use it. So the cosine of pi over 8 is the square root of 2 plus the square root of 2 all over 2. So how can you compute the cosine of 17 pi over 8? Let's see. 17 is almost a multiple of 2 pi, right? If I go forward by another pi over 8, I'll get to 2 pi. Oh, no, it's not. 17 pi over 8, right, so 2 pi would be 16 pi over 8. So cosine of 17 pi over 8, well, that should be the same thing as the cosine of 2 pi plus pi over 8. People are happy with that? All I've done is I've pulled out the extra 2 pi. But wait, what does adding 2 pi to an angle do to the cosine of that angle? Not a damn thing. So I can now erase that 2 pi. Well, not erase, that's written in pen. So that should be the same thing as just the cosine of pi over 8. And what is the cosine of pi over 8? It's the thing that's written above. Equals the square root of 2 plus the square root of 2 all over 2. Same thing. Let's try to compute the cosine of negative pi over 8. What does sticking a negative sign in front of an angle do to its cosine? Cosine is even, so I can drop that negative sign. So this is the same thing as just the cosine of pi over 8, which is square root of 2 plus the square root of 2 all over 2. If you can establish if you know what cosine is, then you can establish what sine is, right? We did that just a little bit last time using the Pythagorean identity. Would people like to see an example of that in practice right now?
Yeah.
Yeah, then let's do it. I don't have space in these notes to do it, but let's do it. Actually, do I? So, like, one option open to me is I can, like, write on the back of my unit circle because I have that sheet open. But I'm going to use the board. You guys can write wherever you want to write. Let's try to compute sine from cosine. Nice, so let's do it. What does the Pythagorean identity say? Not quite. Squared. So one thing which you'll notice in the book, and I'll do occasionally, is I'll put the square just next to the cosine. When you see that written, that just means cosine theta squared. It's just an excuse to have fewer parentheses. But yeah, let's see. The Pythagorean identity holds for every angle theta, so let's apply it at pi over 8. So sine of pi over 8 is the thing that I want to know. So I'll leave that alone. What do I know about the cosine of pi over 8? Well, I know what it is. So if you want to solve this for the sine of pi over 8, I mean, you know what you have to do. You're going to like subtract this to the other side, and then take a square root, and then think about whether it's positive or negative. But maybe before we do that, we should simplify this. What happens when you square a fraction? You just square the numerator, and then you square the denominator? So let's just deal with that. So this will become the sine of pi over 8 squared plus square the numerator. Right, the square of a square root just becomes the thing on the inside as long as it's positive. Divided by 2 squared is 4. Everyone happy enough right now? And since I'm going to subtract this to the other side, I'm going to be proactive and rewrite this one right now as 4 over 4. All right, get a common denominator right now, why not? And now subtract to the other side. sine of pi over 8 quantity squared is 4 minus 2 plus root 2 all over 4. They'll continue right here, because if I go any lower, you guys start being able to not see, right? So I just won't go any lower. Let's rewrite this a little bit. I guess I can distribute that negative sign, and then I'll get 4 minus 2 is 2, and this just has a negative sign in front of it. So what'll I have? I'll have sine of pi over 8 squared is equal to 2 minus the square root of 2 all over 4. And I don't think I can simplify the right-hand side any further. Oh, maybe I'll check with you guys. How many people would want to like cancel this 2 with one of the 2's in the 4? Right, so not everything in the numerator is a multiple of 2. You could rewrite this, if you wanted to, as 1/2 minus root 2 over 4. But everything in the numerator needs to be multiplied by 2 to do that cancellation. So, and I don't want to do this because I'm about to take the square root, and square roots don't play well over subtraction anyway. But yeah, now I guess I just need to take that square root. So sine of pi over 8 is going to be plus or minus the square root of 2 minus radical 2 all over 4. And let's just address some questions. Let's deal with the plus or minus side. Should sine of pi over 8 be positive or negative?
Positive.
Positive. Why positive?
Because the circle is not negative.
Yeah. Right, so if there's pi over 4, pi over 8 should be like half as big. What quadrant is that in? First. So the sign should be positive. And now let's simplify. Do you see any perfect squares under that square root? The whole denominator is 4, right? Which is a perfect square. That's why I didn't want to do this rewriting that was written right here. Nice. Which is hopefully exactly what is typed in the document. Oh, it occurs to me that like I record these lectures. If you're watching this recorded, you didn't see any of the Blackboard stuff. But you would have heard it. Maybe that would have been an argument for me to use paper. Oh well. What is done cannot be undone. So we just computed sine of pi over 8. Let's try to compute these two. And let's do the same thing for this. 15 pi over 8 is almost 2 pi. But I'm short by pi over 8. So that's just a way of rewriting that fact. Sine of 15 pi over 8 is the same thing as the sine of 2 pi minus pi over 8. What happens to sine when you replace an angle by 2 pi minus that angle? Yeah, but say it that way. It becomes negative. So this will be the same thing as negative the sine of pi over 8. And I mean, you knew what you meant when you said it becomes negative. You meant, well, if it's positive, it becomes negative. If it was negative, it would become positive. It gets a negative sign. But it was already positive, so it becomes negative is the right thing to say. Well, and what's the sine of pi over 8? Yeah, which when you say it, it sounds like it should just be 0 because you don't pronounce parentheses, which is really a defect, right? So that should be the same thing as negative the square root of, parentheses, 2 minus root 2 all over 2. People feel pretty good about that? What's the sign of negative pi over 8?
Would it just be root 2 minus square root of 2 over 2 positive?
Almost, but according to the rule up there, what can you do whenever you see a negative sign and point inside of a sign?
One different positive.
So this rule says that you can take that negative sign, and pull it out of the sign function. Sign is odd. So this will be the same thing as negative the sign of pi over 8, which is negative square root of 2 minus the square root of 2 all over 2. And you can always do like a good sanity check. You can just draw a picture and figure out if this number should be positive or negative. If you draw a unit circle, there it is, perfect circle. That's exactly the middle of the circle. And you rotate backwards by an angle of pi over 8. What quadrant does that put you in? Quadrant 4. So sign should be negative, which is a good sanity check whenever you use one of these doodads to make a computation. You should think in terms of that. Just see if your answer is reasonable. Nice. So that's 2 of the identities out of the way. I think we have time to do at least one more. Let's think about what happens when you get an angle of pi minus theta. And there's like a helpful picture here, but let's see how to understand this picture. So if you want to rotate by an angle of pi minus theta, well, here's a way to do it. Let's first rotate forward by a total of theta, and then forward by an angle of pi, and then back by theta. If I want an angle of pi minus theta. So I'll go forward by pi, then I'll go backwards by theta, there's an angle of pi minus theta. So that's the justification for this picture, why there's an angle called theta right here. So now look at these 2 pictures. So there's rotation forward by an angle of theta. There's rotation forward by pi and then backwards by theta. What symmetry of the plane relates those 2 pictures? Reflection over the y-axis. And now you kind of know exactly how the rest of the game is going to go. Maybe I'll even fill in what goes there at the same time as filling in what goes there. So that means the cosine of pi minus theta. That'll be the x-coordinate of this new point. But the new point is given by taking the old point and reflecting over the y-axis. What does reflecting over the y-axis do to x-coordinates?
Makes them negative.
Makes them negative. Oh, if they weren't positive already makes them, if they weren't negative already makes them positive. It negates, well, maybe is the best one, but. So x-coordinates get a minus sign. So that means that the new x-coordinate is exactly negative the old x-coordinate. But what trig function gives you the old x-coordinate? Cosine of theta, I guess. So cosine of pi minus theta is apparently the same thing as negative the cosine of theta. Sine of pi minus theta, that should be the new y-coordinate. What happens to the y-coordinate when you reflect over the y-axis? Well, it stays the same. Y-coordinate stays the same. So sine of pi minus theta is the same thing as the sine of theta. Let's flip back to the front page and write those. Cosine of pi minus theta is the same thing as negative cosine theta. Sine of pi minus theta is the same thing as the sine of theta. Well, so maybe there was even like, that went too fast. But. Do you think we could use this and figure out what secant, cosecant, tangent, and cotangent are? Yeah. Maybe I'll do something similar. I'll compute one of them. Maybe I did secant and tangent last time, so this time I'll do cotangent. And I think this hash should do tangent if you want to not listen to me and instead you'd rather do a computation on your own. You guys should do secant if you don't want to listen to me and instead want to do a computation on your own. And then we'll come together. Oh, in fact, that actually just looks like everyone's doing. So maybe I should just not talk for a second. You guys compute the things that I just asked you to compute, and then we'll come together. Let's come together. What is the secant of pi minus theta? Negative secant theta? What is the tangent of pi minus theta? Negative the tangent of theta. Let's go ahead and check that one really quickly. Tangent is supposed to be like slope of a line. How does the slope of that blue line compare with the slope of that blue line? They look like they're exactly negative of each other. So that checks out. And well, I'll write down the result for cosecant and cotangent. And then I'll ask you guys if you want me to talk through one of those. Does anyone want me to talk through one of those? Okay, everyone's pretty happy. That's good. With 5 minutes, I think we have enough time to at least get sine and cosine for an angle of pi plus theta. Maybe I'll even do it 2 ways. I'll do it the way right here, and then I'll do it by combining previous facts. So, there's an angle of theta, and there's an angle of pi, half of a full revolution. So there's a pi, and then an extra theta. Right here is just an angle of theta. What symmetry of the plane looks like relates those two pictures? Reflection over the origin, maybe also known as fix the origin and rotate by pi radians or 180 degrees. In fact, it's literally exactly that, right? It's 180 degrees and then an extra theta. So it is that. Reflect over the origin. What does a reflection over the origin do to x and y coordinates? It negates both of them. X and y both get negated. So that means that the cosine of pi plus theta, that's the same as the new x-coordinate, is the same as minus the old x-coordinate, is negative the cosine of theta. What about sine? What should sine of pi plus theta become? Negative the sine of theta. Because y new is exactly negative y old. And instead of going to the next sheet and doing the same walk to figure out what secant, cosecant, tangent, and cotangent do, I think I want to get this same identity, but instead by just doing some algebra and appealing to identities we already have. And in order to do that, I'm going to do something which might seem pretty counterintuitive. I will say, well, if I want to compute the cosine of pi plus theta, well, that'll be the same thing as the cosine of pi minus, parentheses, minus theta. Do you guys agree that that's true? Instead of adding theta, I can subtract a negative theta? And that might seem like a dumb thing to do, but have we already established what happens when we do cosine of pi minus a thing? Yeah, what's cosine of pi minus thing? Just negative cosine of thing. So if you like, I'll imagine that this quantity is just something in a box. So I have cosine of pi minus red box. That'll be the same thing as negative cosine of red box. And what is in the red box? Negative theta is in the red box. And what is the cosine of negative theta? It's just cosine theta. And then I'll remember that there's a negative sign on the outside already. So once you have identities, you can put these identities together to get new identities. Sorry, it turns out I had a little bit of coffee on I think I'm drawing that last moment, so now my paper is stained. Cool. So what will happen on Friday is we'll go through the remainder of this note packet. What does that mean? We'll think about what happens when you do pi over 2 minus an angle. And this picture will tell you even what reflection to do. What reflection does it look like relates these two lines? Reflection over the line y equals x. And so that tells you everything. And then to get the last identity, pi over 2 plus theta, we'll do it two different ways. We'll do it once by algebra and once by geometry. And then the last sheet, if you like, is some homework assigned for these 2 days.
Yeah, that's fine.
Awesome. Okay, awesome. I got it. Oh, probably great.